Hello everyone, my name is Demie. I am PhD student at University of Bonn. My research project is a part of Excellence Cluster Phenorope Core Project 5. Today I'm going to share the paper we have published last year, which is the interaction effect of mixture and genotype in cereal legume intercropping. Intercropping is a co-growth of two species in the same land, at least for some specific period of time. It provides a pathway for sustainable agricultural production by reducing the inputs such as fertilizer and pesticides. It increases resource use efficiency, more yield, and biodiversity and weed suppression. However, the performance of intercropping depends on the genotype of the species used in intercropping. There are many literatures that are already published. However, the knowledge is fragmented, and therefore here we want to provide the recent advances by systematic review, linking these different publications. We want to answer firstly, how do different genotype of the species affect intercropping performance? Secondly, what are underlying mechanisms? For this, we conducted a systematic review and analyzed the available literatures. Among the paper which fulfill inclusion criteria and used for analysis, 35 articles reported land equivalent ratio and yielding 262 data points. And land equivalent ratio is actually an index which measures the productivity of an intercropping, and it's calculated as the yield of species 1 in intercropping divided by the yield of species 1 in monocropping plus the yield of species 2 in intercropping divided by the yield of species 2 in monocropping. And this index shows if it is more than 1, so the intercropping is more advantageous, while if it is less than 1, the intercropping is not advantageous. From these 262 extracted data points, 85% of land equivalent ratio of data point is more than 1. This means the intercropping is more advantageous than having monocropping. And the data points below 1 shows that having intercropping is more disadvantageous than monocropping. But the plant density or the planting density also have some significant effect on intercropping performances, and here there is highly significant differences among different species in intercropping under different design, and the different design or different sowing density have also significantly different from each other. So additive design is resulted in more land equivalent ratio compared to replacement design. From a species, there is no significant difference among species in replacement design, but there is a differences in additive design where millet reaches higher land equivalent ratio compared to other species. When we compare the legumes, different legume species, there is no differences among sowing density or design, but there is significant differences between the species. But however, if we test a large number of genotype of different species in intercropping, it could be result in more land equivalent ratio or less land equivalent ratio. For example, here we take the data from maize extracted from 16 published paper. And as you increase the number of genotypes combination, the variation of land equivalent ratio increases, while there is so the red point shows below 0 where you have less advantage of intercropping, and the other blue and green line shows it is more than 1, so it is the land equivalent ratio is more than 0. But what are the mechanisms which underlays this all? So the first one is phenological difference of the two species that is resulted in temporal niche complementarity, where the two species have different, let's say, different maturity, so they use resources at different time, or morphological differences, example, resulted in spatial complementarity. For example, if one of the species is taller and the other is shorter, let's say they use resources at different level. So it is important to test a high number of genotypes under different location. However, it is difficult to test this many genotypes of different species under different location. It is difficult and laborious. And for this, maybe the complex interaction in intercropping can be disentangled or can be solved by process-based agroecological models. This is all what I want to say. Thank you very much for watching, and I recommend you to read my paper.